So now we're going to fill in the rest of the unit circle. So at the end of this, what we'll have is a guide with all of these different angle measurements with their matching coordinates. And with that, these XY coordinates link to sine and cosine. Cosine being the X coordinate, sine being the Y coordinate. So if we're doing work and we need to evaluate sine or cosine of a certain angle, we can find it just based on this unit circle right here and specifically getting an exact value. But all of it roots from this first quadrant and the idea of those two triangles, the 45-45-90 and the 30-60-90. So first, to get started, let's go ahead and fill in the angle measurements. So I'm going to go through and mark our important ones. There's 0 degrees, 90 degrees, 180, 270, and 360. And I'm going to go ahead and fill in the radians for those two. So 0 degrees in radians is just 0, 90 is the pi over 2, 180 is pi, and at 270 is 3 pi over 2. And then 360 is 2 pi. All right, then from there, I'm going to go ahead and fill in the 45s. So 45 degrees plus 45 is 90, plus 45 is 135, plus 45 is 180, 225, 270, 315, 360. Now in radians, those are units of pi over 4. So we have 1 pi over 4, 2, 3 pi over 4, and 4 pi over 4, 5 pi over 4, 6, 7, and then 8 at the 2 pi. All right, how about 30-degree increments? So we have 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, 360. Now those increments were pi over 6. So we have 1 pi over 6, 2 pi over 6, 3, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, and 11 pi over 6. Sorry, that was hard to say one number, but I was reducing down into those thirds there. All right, so that's how we get our angle measurements out. So it's a matter of moving around those increments in degrees and radians. Now what I'm going to do is I'm going to fill in the points that land on the x and y axes. So we have our coordinate 1, 0, we have 0, 1, negative 1, 0, and 0, negative 1. All right. Now, you'll notice something. This is a form that I like to use for filling in the unit circle because I love that it kind of gives the spaces for everything and in a pretty clear manner. Another thing that I like is how it goes by quadrant of positive and negative. And I like to write these little reminders, like if we're in the first quadrant, x and y are going to be positive. When we're in the second quadrant, we'll have negative x values, but positive y values. So it's y will be positive. Ooh, sorry, that got messy. I'm pretty zoomed out right now. Y, and then x will be negative. When we're in the third quadrant, both will be negative. So we'll have x and y are both negative. And then in the fourth quadrant, x is positive, y is negative. So what that will help is that I could even go through and fill in the negative symbols. So like all of these y coordinates are going to be negative. And over here, both x and y are going to be negative. And up here, x is going to be negative. So with that, we can have our symbols filled in just based on which quadrant we're in. All right, so we know our first quadrant based on those triangles. So we could do is fill in that first quadrant. You go ahead and I'm going to use 3 different colors here. So for 30 degrees, that's where x is long and y is short. For our 45 degrees, they're the same. And for our 60 degrees, it's x is short, y is long. All right. So the rest of these values come through with reflection. So let's look at how this coordinate of 1/2 and √3/2 moves around. So how it moves is a reflection over the y-axis to 2π/3. So what that's going to do is y is going to stay positive, y is exactly the same, but x has changed from positive to negative. So the numbers stay the same though. This is 1/2, this is √3/2, it's just x is negative now. How you can also see this is again by just drawing the triangle, and you can see, okay, x is short, but it's also negative since it's going to the left, and y is long. So as long as you see that x is short and negative and y is positive and long, then you would get those 2 pieces. Then our next piece, let's see, I need to zoom out to get down here. The next one's a reflection over the x-axis. So we can see as we still have this x-coordinate that's negative and short, and now for y, we have negative and long. So we still have this x-coordinate of 1/2, y-coordinate of √3/2 is just landing over here. They're both negative. And then we have this reflection over to this point. So this is going across the y-axis. So y is staying exactly the same. So y is still going to be negative, but then our x-coordinate is going to be positive now that we're on this side. So this will be 1/2 and √3/2, which is now negative. What it comes down to is in each of those quadrants, I can imagine that 30, 60, 90 triangle, and it is just a matter of, for all of those, x is short and y is long, but which one's positive and which one's negative. But with x being short, that means we're always seeing a 1/2 there. With y is long, we're always seeing that √3/2, which just changes as the direction. Now the same idea happens with this √2/2, where we have these reflections. These values are always going to be √2/2, but what's just going to change is the sign positive versus negative. So here, we're going to have a negative √2/2, since x will be negative, but y will still be positive. Down here, both will be negative because we're in the 3rd quadrant. And over here, x will be positive, y will be negative. So see how that coordinate just moves around? We still have that 45, 45, 90 triangle at every single spot. It's just a matter of, is x positive or negative, and same for y. Oh, I switched colors. Sorry. Just to keep it consistent. I'm going to change the blue here. I know it doesn't matter that much, but just for my own organization. Okay, there we go. All right, so our last one is moving around this point where x is long and y is short. So when we're over here, we can see we have x is long and negative, and then we have y is short. So that's going to be our negative √3/2 and 1/2. Down here, same, x is long, y is short, but they're both negative this time. And over here, same triangle, but now x is positive, y is negative. And there is our filled in unit circle. So when we get to actually using these values, because right now you might just be like, why is this happening? What are we doing? And in the next video, we'll actually go through some examples with these. But it's just an idea of, we're going to refer to these angle measurements. We're going to plug them into a sine function or a cosine function. And the idea is that all around this circle, so every x coordinate that we have on this circle is a cosine value. And every y coordinate is a sine value. So sine for these different angles. So that, let's say I was at 210 degrees and I needed to know what sine of 210 degrees is, or I could even use the radian form. Let's say I wanted to know what cosine of 7 pi over 6 is. Well, what I'm going to use is, well, we can use this unit circle as a reference, but I can use the idea of knowing where it lands within the circle and what sort of triangle it's making. And based on where we land, so sine uses the y coordinate, cosine uses the x coordinate. So what we can then end up doing is making these substitutions where we have our trigonometric function. We can replace it with an actual value. And it's coming from this coordinate along the outside of this unit circle. Now, in our module, I have uploaded a blank copy of this, and you probably printed a blank copy with your notes, or if you're not using a printer, that's fine too. But I recommend just playing around with this, and while I kind of mentioned the patterns that I like to draw from in doing this, you may find some other patterns, and that is fantastic too. Use whatever clicks best for your brain. But what I recommend doing is just, I don't know about every day, but every other day, maybe just print off a blank one and see if you can make this from memory. But just drawing on those two triangles, the 45, 45, 90, and that 30, 60, 90.